Hey, sixth graders. So we have already reviewed the basics of volume. So if you haven't watched that video, go back and check out our review of volume for sixth grade, okay? Now we are going to apply those same volume practices and understanding to be able to solve some more in-depth questions that you haven't necessarily seen in fifth grade, okay? So in fifth grade, you solved for volume, or you calculated the volume of 3D shapes. Usually they were rectangular prisms, using length times width times height, and using only whole numbers. In sixth grade, we're gonna talk about, okay, what if those sides, what if those dimensions actually end up being fractions? How do we do that? And we're also going to talk about what if one of the dimensions is missing? How do we solve those? So in today's video, we're still under G.A.2 for sixth grade, that geometry standard A2. And we're going to be solving volume questions with fractional sides or missing dimensions. These are two different types of questions that you will see related to volume in sixth grade math. So the first one is, what if we are given a volume question where the sides are no longer whole numbers, they are used as fractions? Well, one of the things that I always do when I see volume in a question, I'll automatically box it in and I write down the formula that we're going to use, okay? So it says, find the volume, okay, volume, and I'm gonna automatically write volume equals length times width times height. Given that length equals 1/2, width equals 3/4, and height equals 2 1/4. So I've done two things. The first thing I did was box in the word volume and automatically write down the formula. Now I've also identified my three dimensions that are here and what they will equal. So now I'm going to write myself the variable and the value that it is going to be related to. So length, L, is going to equal 1/2. And now this becomes a substitution problem. Every time I see an L in the formula, I'm putting 1/2. The next one, width, W, equals 3/4, and height, H, equals 2 1/4. So now, I'm ready to just plug in those values where the variables were. So I have volume equals 1/2 times 3/4 times 2 1/4. Now, I want to stop here and let you know that hopefully you remember that a fraction is equivalent to a decimal. And you can find a decimal by typing in your calculator or dividing out the numerator divided by the denominator. So for example, 1 divided by 2 is 5/10. 3 divided by 4 is 75/100. Okay, so if you wanted to make these into a decimal, you could. Here's the problem that arises there. If you are turning everything into a decimal and the answer is given only in fractions, then you would have to reverse that decimal back into, or convert that decimal back into a fraction to be able to get your answer. So turning it into a decimal, using your calculator to do that would be a good thing to check your work. But these problems, this volume with fractional sides, is not really meant to be used in decimal form only, because we want you to know how to multiply fractions. Now, you learned how to multiply fractions in fifth grade, so we're utilizing that skill now, okay? So if you'll remember, when you multiply fractions, you multiply numerator times numerator and denominator times denominator, okay? You go straight across. The reason I cannot go straight across right now is because of 2 1/4. Hopefully you're looking at this and you're saying, oh, that is called and it's a mixed number. So a mixed number is a really nice way of writing an improper fraction. So in order to just have a numerator and a denominator and not have a whole number, I'm going to convert this mixed number back into an improper fraction so that I can use it, all right? So I'm going to say 2 times 4 is 8, plus 1 more is 9. And that is something that you learned in fifth grade. Okay, So now I'm ready. I've got all of my my fractions here, and now I can multiply numerator times numerator, denominator times denominator. Now, another thing to point out is you can always simplify if there is a numerator and a denominator that can both be divided by the same factor. In this case, 1 cannot be divided by anything because it's a prime number, so it's only divisible by itself. 3 cannot be divided by any of our denominators because it is a prime number, which means it's only divisible by 1 and itself. 9 cannot be divided by any of our denominators because it only has the factors of 1, 9, and 3. So that means I'm not going to worry about simplifying. I'm going to just multiply it across. 1 times 3 is 3, and 3 times 9 is 27. Then I have 2 times 4 is 8, and 8 times 4 is 32. Now, another way that you may want to think about that is you can say 4 times 4 is 16, and 16 times 2 is 32. Because of the commutative property of multiplication, the order doesn't matter as long as we're multiplying. So this is my final answer, except for it is not finished yet. In fact, when I talk to my students in class, I'll say, okay, what's the answer? And if they were to just give me 27 over 32 or 27 divided by 32, I would say your answer is incorrect because we need to add units cubed. Now, this is units because the question didn't tell me specifically what unit of measurement we're using, so it's going to be units, okay? So in fractional sides, you literally just solve for volume. You calculate it just like normal, except for you're calculating with your multiplying fractions instead of whole numbers, and that is a 5th grade skill that you have been reviewed on, okay? Now, let's turn to another special question that you may have in volume, and that is if there's a missing dimension, okay? So in a missing dimension, you are really solving an equation, okay? So right over here, it says, what is the length? So I'm going to go ahead and I'm going to start looking for those keywords. What is the length, okay, of a rectangular prism if the volume is 48 inches cubed and the width is 12 inches, okay? Now, if you look at this question, you automatically say, wait a minute. I can't find volume with only width and length. What else are we missing? Well, we are also missing a height, okay? So let's say, what is the length of a rectangular prism if the volume is 48 inches cubed, the width is 12 inches, and the height is 2 inches. Now, the reason I left this blank is because I want you to notice that if there's only 2 dimensions like length and width as there were before, it doesn't need to be volume. What would it need to be? Hopefully you learned in our last video that it would be area with length and width only and not height. When we add in that 3rd dimension, that's where the volume comes from, and that's where we get our cubed units. So when I see volume, just like over here, first thing I'm going to do is write volume equals length times width times height. And now I'm going to fill in what I know. Well, it says, what is the length? So I put length question mark because I don't know what it's equal to. Volume is equal to 48 inches cubed. Width is equal to 12. And height is equal to 2. So the first thing you're going to do is you are going to plug in your values for the dimensions that are here, for the variables that are here. So I'm going to rewrite my formula now, but instead of V, I'm going to put in 48. I'm going to substitute in. For L, I'm going to put L because I don't know a value to substitute in. For W, I'm going to sub in 12. And for H, I'm going to sub in 2. Now, you've heard me say this is a substitution problem. You've heard me say the word I'm going to sub in. So I just want to really quickly point out the fact that a variable is just a placeholder until you know what digit or what value to put in. And when you hear the word substitution, that should make you think of maybe a football game or a basketball game when you have a teammate on the bench who buzzes in to come play. And so, for example, if the quarterback is going to come back on the bench, only one quarterback is out at a time unless they're doing some special play, and they swap places. In the same way, in a substitution problem, we move the variable out because now we have a value to plug in, and we're subbing in that value in that spot. So now I work the problem. Well, the first thing I'm going to do is clean up this side because I'm trying to get L by itself. So the very first thing I'm going to do is I'm going to multiply 12 times 2. And I'm going to bring everything else down. Okay, and I'm going to write my L a little different so you know it's not just a 1. And 12 times 2 is 24. Well, now this is solving an equation for a variable. So I'm going to do the inverse operation. Now I'm going to write that word here, and I hope you know that an inverse operation is the opposite operation. It reverses the calculation. All right, so I have 48 equals L times 24. Well, if I am multiplying here, the inverse or the opposite, what's going to reverse multiplication is division. So I'm going to divide both sides by 24. And when I say both sides, I mean that equal sign. That equal sign is where our two sides go. We're trying to keep both sides equal because equal means the same. If I do something to one side and not the other, they are no longer equal, okay? So we're trying to keep them balanced. So now, when I do this on both sides, 48 divided by 24 is going to be 2. I'm going to bring L down, and 24 divided by 24 is 1, which kind of cancels it out to just be 1. So now L, or length, is equal to 2. Now, hopefully you remember from solving equations, you could always plug in the L here and make sure it works. So for example, I could plug in 2 for the L and say, okay, what is, when I get to 12 times 2, I get to 24. 24 times 2 should equal 48 if this is accurate. Now, if you'll notice, on this one, they did have inches, okay? And so I would put the length equals 2 inches. I do not put cubed here because I didn't solve for the volume. I solved for the length, all right? And if you'll notice in the volume, it does have inches cubed. Thank you for joining us today.